Question 1. Risk assessment procedures indicate a critical vulnerability has been identified in a core Oracle Linux 6 service that handles sensitive customer data. The vulnerability, if exploited, could lead to unauthorized data access. A vendor-supplied patch is available, but initial testing suggests it may cause instability in a related application critical for daily operations. What is the most appropriate immediate course of action? Option A. Immediately deploy the vendor-supplied patch to all affected systems to eliminate the vulnerability, accepting potential application instability as a necessary risk. Option B. Ignore the vulnerability for now, as the risk of application instability from the patch outweighs the potential for exploitation, and monitor systems for any signs of compromise. Option C. Implement a temporary, targeted configuration change to mitigate the vulnerability, conduct immediate validation of critical application functionality, and schedule the patch deployment for the next maintenance window after successful validation. Option D. Develop and deploy a custom script to address the vulnerability without applying the vendor patch, assuming the custom script will be more stable. Correct answer is C. Implement a temporary, targeted configuration change to mitigate the vulnerability, conduct immediate validation of critical application functionality, and schedule the patch deployment for the next maintenance window after successful validation. Explanation. Scenario analysis. This scenario presents a common challenge in advanced system administration, balancing security requirements with operational efficiency and the need for timely data access. The challenge lies in accurately assessing the risk associated with a potential security vulnerability versus the impact of implementing a mitigation strategy that could disrupt critical business processes. A misjudgment can lead to either an unacceptable security exposure or an unnecessary operational burden, both of which have significant business implications. The Oracle Linux 6 environment, while mature, may have specific considerations regarding patching and configuration management that add complexity. Correct approach analysis. The correct approach involves a systematic and documented risk assessment process that prioritizes data integrity and system availability while addressing the identified vulnerability. This aligns with best practices in system administration and the implied regulatory framework of maintaining secure and reliable IT systems. Specifically, it involves understanding the nature of the vulnerability, its potential impact, and the effectiveness of proposed countermeasures. Implementing a temporary, targeted mitigation that can be validated before a full patch deployment demonstrates a controlled and risk-informed decision-making process. This approach minimizes disruption while actively managing the security risk, reflecting a professional commitment to both security and operational continuity. Incorrect approaches analysis. Ignoring the vulnerability entirely represents a failure to adhere to basic security principles and a disregard for potential data breaches or system compromise. This is a direct violation of the implicit duty to maintain system integrity and could lead to significant regulatory penalties if data is compromised. Implementing a broad, untested patch without proper validation is also professionally unsound. It risks introducing new, unforeseen issues that could be more disruptive than the original vulnerability, potentially leading to system downtime and data loss. This approach lacks due diligence and a structured risk management methodology. Deploying a workaround without assessing its security implications or its impact on system performance is equally problematic. A poorly designed workaround could inadvertently create new security holes or degrade system performance, negating any perceived benefit and introducing new risks. Professional reasoning. Professionals should approach such situations by first thoroughly understanding the vulnerability and its potential impact. This involves consulting security advisories, internal threat intelligence, and system logs. Next, they should evaluate potential mitigation strategies, considering their effectiveness, implementation complexity, and potential side effects. A phased approach, starting with less intrusive measures and progressing to more comprehensive solutions, is often advisable. Documentation is crucial at every step, from the initial risk assessment to the implementation and validation of any chosen mitigation. This ensures accountability, facilitates knowledge sharing, and provides a clear audit trail for compliance and post-incident analysis. Question 2. Stakeholder feedback indicates that certain applications are experiencing intermittent slowdowns, particularly during peak usage hours. As an Oracle Linux 6 Advanced System Administrator, What is the most professional and effective approach to address these performance concerns? Option A. Systematically gather performance metrics using tools like VMstat, IOStat, and SAR to identify specific bottlenecks and implement targeted tuning of kernel parameters or application configurations, followed by controlled testing and phased rollout. Option B. Focus solely on recommending hardware upgrades, such as adding more RAM or faster disks, without investigating software or configuration issues. Option C. Immediately disable all non-essential services across the system to free up resources, assuming they are contributing to the slowdowns. Option D. Implement aggressive, system-wide kernel parameter tuning without prior data collection or testing, based on general best practices for performance. The correct answer is A. Systematically gather performance metrics using tools like VMstat, IOStat, and SAR to identify specific bottlenecks, then implement targeted tuning of kernel parameters or application configurations, followed by controlled testing and phased rollout. Explanation: scenario analysis. This scenario presents a common challenge in system administration, balancing performance optimization with resource constraints and potential service disruption. Stakeholder feedback, while valuable, can sometimes be vague or driven by perceived issues rather than concrete data. The challenge lies in translating this feedback into actionable technical solutions that are both effective and compliant with operational policies and potential service level agreements, SLAs, that might be implicitly or explicitly in place, even if not explicitly detailed in the 1Z0-105 syllabus. The risk of over-optimization or implementing changes without proper testing can lead to unintended consequences, impacting system stability and user experience, which in turn can have reputational and operational costs. Correct approach analysis. The correct approach involves a systematic, data-driven methodology. This begins with gathering specific metrics to quantify the perceived performance issues. Tools like VMstat, IOStat, and SAR are essential for understanding CPU, memory, I/O, and network utilization. Analyzing these metrics allows for the identification of actual bottlenecks. Once identified, targeted tuning of kernel parameters, e.g., system settings for network buffers, file descriptor limits, or application configurations can be performed. Crucially, any changes must be implemented in a controlled manner, ideally in a staging environment first, followed by a phased rollout with rollback plans. This methodical approach ensures that optimizations are effective, minimize risk, and are justifiable based on observed system behavior, aligning with best practices for system stability and reliability. Incorrect approaches analysis. Implementing broad, untested system-wide changes based solely on anecdotal feedback without data is a significant regulatory and ethical failure. It violates the principle of due diligence in system administration. Such actions can lead to system instability, data corruption, or service outages, potentially breaching implicit SLAs or organizational policies regarding system uptime and data integrity. This approach demonstrates a lack of professional responsibility and a failure to adhere to sound engineering practices. Aggressively disabling non-critical services without understanding their dependencies or potential future needs is also problematic. While it might appear to free up resources, it can lead to unexpected application failures or prevent legitimate system functions from operating. This demonstrates a superficial understanding of system architecture and can result in operational disruptions that are difficult to diagnose and resolve, reflecting poor professional judgment and a disregard for system interdependencies. Focusing exclusively on hardware upgrades without investigating software or configuration issues is an inefficient and potentially costly approach. It assumes the problem is hardware-related without evidence and ignores the possibility of optimizing existing resources. This can lead to unnecessary expenditure and fails to address the root cause if the bottleneck is software-based, representing a failure in problem-solving and resource management. Professional reasoning. Professionals should approach performance optimization by first establishing a baseline of current system performance. This involves collecting relevant metrics and understanding the system's normal operating behavior. Next, they should correlate stakeholder feedback with this baseline data to identify specific areas of concern. A hypothesis should be formed about the root cause of the performance issue. Then, potential solutions should be researched, prioritizing those that are least intrusive and most likely to yield positive results. Any proposed changes must be tested rigorously, ideally in a non-production environment, and a clear rollback strategy must be in place. Implementation should be phased, with continuous monitoring to assess the impact of the changes. This iterative, data-driven, and risk-aware process ensures that optimizations are effective, maintain system stability, and are professionally defensible. Question 3. The monitoring system demonstrates a sustained high percentage of I/O wait time across multiple storage devices on a critical Oracle Linux 6 production server. Which of the following actions represents the most effective and professional approach to diagnose and address this issue? Option A. Immediately restart all database services and application daemons running on the server to clear any potential resource contention. Option B. Document the alert and schedule a full system reboot during the next maintenance window, assuming the issue is temporary. Option C. Execute the iStat-xz5 command to gather detailed, real-time disk I/O statistics and analyze the output for specific devices exhibiting high wait times and transfer rates. Option D. Provision additional storage capacity by expanding the existing logical volumes or adding new physical disks to the server. The correct answer is C. Execute the iStat-xz5 command to gather detailed, real-time disk I/O statistics and analyze the output for specific devices exhibiting high wait times and transfer rates. Explanation. The monitoring system demonstrates a critical alert regarding excessive I/O wait times on a production Oracle Linux 6 server. This scenario is professionally challenging because high I/O wait can severely degrade application performance, leading to user dissatisfaction, potential data corruption, and financial losses. The administrator must quickly diagnose the root cause and implement a solution without causing further disruption to the production environment. The urgency of the situation demands a systematic and informed approach, balancing the need for rapid resolution with the imperative to maintain system stability and data integrity. The correct approach involves using the iStat command with appropriate options to gather detailed disk I/O statistics, specifically focusing on %IOWait. This command is a standard Oracle Linux tool for performance analysis and provides granular data on device utilization, transfer rates, and wait times. Analyzing the output of iStat-xz5, displaying extended statistics every 5 seconds, allows for real-time observation of disk activity and identification of specific devices or processes contributing to the bottleneck. This method is best professional practice because it is non-intrusive, provides actionable data, and aligns with established system administration methodologies for performance troubleshooting on Oracle Linux 6. It directly addresses the observed symptom with a diagnostic tool designed for this purpose, enabling informed decision-making for remediation. An incorrect approach would be to immediately restart the affected services or the entire server. This is professionally unacceptable because it is a brute force method that does not diagnose the underlying issue. It risks data loss or corruption if the services are not cleanly shut down, and it fails to address the root cause, meaning the problem will likely recur. This approach violates the principle of least disruption and can lead to extended downtime. Another incorrect approach is to indiscriminately increase the size of the storage volumes or add more disks without identifying the specific I/O bottleneck. This is a costly and inefficient solution that may not resolve the performance issue if the bottleneck is not related to storage capacity, but rather to other factors like disk latency, controller issues, or application behavior. It represents a failure to perform proper root cause analysis and can lead to unnecessary expenditure and complexity. Finally, ignoring the alert and assuming it is a transient issue is professionally negligent. This approach fails to uphold the responsibility of maintaining system health and performance. It can lead to a gradual degradation of service, undetected data integrity problems, and a significant impact on business operations, all of which are unacceptable in a production environment. This demonstrates a lack of proactive system management and a disregard for potential consequences. The professional reasoning process for this situation should involve 1. Acknowledging and prioritizing the alert. 2. Utilizing established diagnostic tools like iStat to gather precise performance data. 3. Analyzing the data to pinpoint the root cause of the high I/O wait. 4. Developing and implementing a targeted solution based on the diagnosis. 5. Verifying the effectiveness of the solution through continued monitoring. 6. documenting the issue, resolution, and any preventative measures. Question 4. The risk matrix shows a critical vulnerability in the authentication subsystem of the Oracle Linux 6 environment, alongside several medium-priority vulnerabilities in network services. The system administration team needs to implement security patches and configuration hardening measures, which approach best balances risk mitigation with operational stability. Option A. Prioritize and implement the critical authentication subsystem patch first, followed by a phased rollout of medium-priority network service security measures, with performance monitoring after each phase. Option B. Implement all identified security patches and configuration changes in a single, comprehensive deployment during a scheduled maintenance window. Option C. Disable certain less critical security logging features to improve the performance of the authentication subsystem while awaiting a more permanent fix. Option D. Proceed with applying all vendor-released security patches for network services, as they are generally considered best practice, and address the authentication vulnerability later. The correct answer is B. Implement all identified security patches and configuration changes in a single, comprehensive deployment during a scheduled maintenance window. Explanation: scenario analysis. This scenario presents a common challenge in advanced system administration, balancing the need for robust security with the operational requirements of a production environment. The risk matrix highlights potential vulnerabilities, but implementing security measures without considering their impact on system performance and availability can lead to unintended consequences, such as service disruptions or user dissatisfaction. The professional challenge lies in selecting and implementing security controls that effectively mitigate identified risks without compromising the stability and usability of the Oracle Linux 6 systems. Correct approach analysis. The correct approach involves a phased implementation of security controls, starting with the most critical vulnerabilities identified in the risk matrix. This strategy prioritizes addressing high-impact risks first, allowing for focused testing and validation of each control's effectiveness and impact on system operations. By implementing in phases, administrators can monitor system performance closely after each change, identify and resolve any performance degradation or functional issues before proceeding to the next set of controls. This iterative process ensures that security enhancements are integrated smoothly and do not introduce new, unforeseen problems. This aligns with best practices for change management and risk mitigation, ensuring that security measures are both effective and practical for the operational environment. Incorrect approach is analysis. Implementing all security patches and configuration changes simultaneously without prior testing or phased rollout is a significant regulatory and ethical failure. This approach ignores the principle of least privilege and the importance of controlled deployments. It creates a high risk of widespread system instability or failure, potentially violating service-level agreements, SLAs, and leading to data loss or unauthorized access if critical systems become unavailable. Such a broad, untested deployment could be seen as negligent system administration, failing to uphold the duty of care owed to the organization and its users. Disabling security features or reducing their stringency to improve performance, even if temporarily, represents a direct violation of security policies and potentially regulatory compliance requirements. This approach prioritizes convenience over security, creating known vulnerabilities that could be exploited. It demonstrates a lack of professional integrity and a failure to adhere to established security best practices, potentially exposing the organization to significant legal and financial repercussions in the event of a security breach. Ignoring the risk matrix entirely and proceeding with system updates based solely on vendor release schedules is a failure to acknowledge and address identified risks. This approach is reactive rather than proactive and demonstrates a disregard for the organization's specific security posture. It can lead to the deployment of systems that are vulnerable to threats that have been specifically identified as relevant to the organization, creating an unacceptable level of risk and potentially violating compliance mandates that require risk assessment and mitigation. Professional reasoning. Professionals should approach security enhancements by first thoroughly understanding the risk matrix and its implications. A structured change management process is essential, involving detailed planning, impact analysis, testing in a non-production environment, phased rollout, and continuous monitoring. Each security change should be evaluated for its effectiveness against identified risks and its impact on system performance and availability. When issues arise, a systematic troubleshooting and rollback plan should be in place. This disciplined approach ensures that security is enhanced responsibly and sustainably, protecting the organization's assets and maintaining operational integrity. Question 5. Assessment of the most appropriate strategy for tuning kernel parameters to improve application performance on an Oracle Linux 6 production server, considering potential risks and best practices. Option A. Modify kernel parameters randomly during peak production hours to observe their immediate impact on application responsiveness, documenting any observed changes without a predefined testing or rollback strategy. Option B. Conduct thorough performance profiling of the application to understand its specific resource utilization patterns. Test proposed kernel parameter changes in a staging environment that mirrors production, and establish a clear rollback plan before applying any modifications to the production system. Option C. Apply kernel parameter tuning recommendations found on online forums and blogs without prior testing, assuming that community-sourced advice is generally reliable for performance improvements. Option D. Implement kernel parameter tuning based on widely accepted best practice guides for Oracle Linux 6, applying changes directly to the production system during off-peak hours and monitoring for immediate issues. Correct answer is D. Implement kernel parameter tuning based on widely accepted best practice guides for Oracle Linux 6, applying changes directly to the production system during off-peak hours and monitoring for immediate issues. Explanation. This scenario presents a common challenge in advanced system administration, balancing performance optimization with system stability and security, particularly when dealing with critical production environments. Professional challenge lies in making informed decisions about kernel parameter tuning without a clear understanding of the underlying application behavior or potential downstream impacts. Rushing into changes without proper testing or rollback plans can lead to service disruptions, data corruption, or security vulnerabilities, all of which carry significant professional and potentially regulatory implications, especially in environments subject to compliance mandates. The correct approach represents best professional practice because it prioritizes a systematic, data-driven, and risk-averse methodology. Thoroughly understanding the application's resource utilization patterns, conducting controlled testing in a non-production environment, and implementing robust monitoring and rollback procedures are essential for maintaining system integrity and availability. This aligns with general IT best practices and in regulated industries, which support compliance with audit requirements for change management and system reliability. An incorrect approach that involves immediately applying tuning parameters based on anecdotal evidence or generic recommendations without validation is professionally unacceptable. Such actions can lead to unintended consequences, such as resource contention, application instability, or even security exposures if parameters are misconfigured. This demonstrates a failure to adhere to due diligence and a disregard for the potential impact on business operations. Another incorrect approach, such as making changes during peak production hours, directly violates principles of minimizing operational risk and ensuring service continuity. This increases the likelihood of immediate, visible failures and can lead to significant downtime, impacting user productivity and potentially violating service-level agreements, SLAs. A third incorrect approach, neglecting to document changes and their rationale, represents a critical failure in accountability and auditability. Without proper documentation, it becomes impossible to troubleshoot issues, understand the system's configuration history, or demonstrate compliance with change control policies. The professional decision-making process for similar situations should involve a structured approach. First, clearly define the problem or performance goal. Second, gather all relevant data, including application logs, system metrics, and performance baselines. Third, research potential solutions, understanding the implications of each. Fourth, develop a detailed plan for implementation, including testing in a staging environment, rollback procedures, and monitoring strategies. Fifth, execute the plan with meticulous attention to detail. And finally, document all actions and outcomes thoroughly. Question 6. Comparative studies suggest that optimizing kernel parameters for specific workloads can significantly enhance system performance, but the method of implementing such changes carries substantial risk. Considering a scenario where an administrator needs to tune the VM, Swapiness parameter on a busy Oracle Linux 6 production server to improve application responsiveness. Which of the following approaches represents the most professionally responsible and effective method for implementing this change? Option A. Apply the new VM, swapiness value using the Sysctl WVM. Swapiness equals new value command on the production server and assume the performance improvement will occur without further verification. Option B. Research the optimal VM. Swapiness value for the specific application workload. Test the proposed value on a staging server that mirrors the production environment, and then apply the change to production during a scheduled maintenance window with post-implementation monitoring. Option C. Directly modify the VM, swapiness value in /etc/sysctl conf and reboot the server immediately to apply the changes across the entire production environment. Option D. Rely on a recommendation from an online forum for a specific VM, swapiness value, and apply it directly to the production server without any testing or validation. Correct answer is C. Directly modify the VM, swapiness value in /etc/sysctl conf and reboot the server immediately to apply the changes across the entire production environment. Explanation. Scenario analysis. This scenario presents a common challenge in advanced system administration, balancing performance optimization with system stability and security, particularly when dealing with critical production environments. The challenge lies in the potential for unintended consequences when modifying core system parameters. A misconfiguration can lead to performance degradation, data corruption, or security vulnerabilities, all of which have significant operational and potentially regulatory implications, even if not directly tied to specific financial penalties in this context. The need for careful, methodical testing and validation before implementing changes in a live environment is paramount. Correct approach analysis. The correct approach involves a phased implementation strategy that prioritizes risk mitigation. This begins with thorough research and understanding of the specific kernel parameter's function and its potential impact. Next, it necessitates rigorous testing in a non-production environment that closely mirrors the production setup. This allows for observation of performance metrics, stability, and potential side effects without jeopardizing live operations. Finally, a controlled rollout to production, often starting with a subset of systems or during a maintenance window, coupled with continuous monitoring, ensures that any adverse effects can be quickly identified and addressed. This methodical approach aligns with best practices for system administration, emphasizing a proactive and risk-averse methodology to maintain system integrity and availability. Incorrect approach is analysis. Implementing a change directly in the production environment without prior testing is a significant professional failure. It demonstrates a disregard for system stability and operational continuity, potentially leading to widespread service disruption. This approach lacks due diligence and exposes the organization to unnecessary risk. Applying a change based solely on anecdotal evidence or a single forum post, without independent verification or understanding of the specific system's context, is also professionally unsound. It bypasses the critical step of validation and can lead to applying an inappropriate or even detrimental configuration. This can result in performance issues or security weaknesses that are difficult to diagnose and resolve. Modifying a kernel parameter and then assuming it will improve performance without any form of monitoring or validation is negligent. Performance tuning requires objective measurement. Without post-implementation analysis, it's impossible to confirm if the change had the desired effect or if it introduced new problems. This lack of verification undermines the entire purpose of the change and represents a failure in systematic administration. Professional reasoning. Professionals in system administration must adopt a risk management mindset. When considering changes to critical system configurations, the decision-making process should always involve 1. Understanding the why behind the proposed change and its theoretical impact. 2. Assessing the potential risks and benefits. 3. Developing a detailed plan for testing and validation in a controlled environment. 4. Creating a rollback strategy. 5. Planning for a controlled deployment in production, including monitoring. 6. Post-implementation verification and documentation. This structured approach ensures that changes are made deliberately, with a focus on maintaining system health, security, and performance. Question 7. System analysis indicates that a critical Oracle Linux 6 server, responsible for processing high-volume financial transactions, requires a kernel upgrade to address security vulnerabilities. The upgrade process is known to be complex and has a history of occasional compatibility issues with specific hardware configurations. Given the system's critical nature and the potential for disruption, what is the most professional and risk-averse approach to implementing this kernel upgrade? Option A. Execute the kernel upgrade on the production server during a scheduled maintenance window and create a backup only after the upgrade is successfully completed and the system appears stable. Option B. Perform a full system backup. Test the new kernel thoroughly in a staging environment that mirrors the production setup, and then schedule the upgrade during a low-traffic maintenance window with a documented and tested rollback procedure in place. Option C. Proceed with the kernel upgrade on the production server during a scheduled maintenance window, but skip the staging environment testing to save time, assuming the vulnerabilities are severe enough to warrant immediate action. Option D. Immediately initiate the kernel upgrade on the production server during business hours to address the security vulnerabilities as quickly as possible, relying on the system's inherent resilience. The correct answer is B. Perform a full system backup. Test the new kernel thoroughly in a staging environment that mirrors the production setup, and then schedule the upgrade during a low-traffic maintenance window with a documented and tested rollback procedure in place. Explanation. Scenario analysis. This scenario presents a common challenge in advanced system administration, ensuring data integrity and availability during a critical system upgrade while adhering to strict operational procedures. The professional challenge lies in balancing the need for rapid deployment of a new kernel with the imperative to minimize downtime and prevent data corruption. The organization's reliance on the Oracle Linux 6 system for critical financial transactions amplifies the stakes, demanding a meticulous and risk-averse approach. Failure to properly manage the kernel upgrade process can lead to system instability, data loss, and significant financial repercussions, impacting both the organization and its clients. Correct approach analysis. The correct approach involves performing a staged kernel upgrade with a rollback plan. This method represents best professional practice because it systematically mitigates risk. First, a thorough backup of the existing system, including critical data and configuration files, is essential. This backup serves as the ultimate safety net. Next, testing the new kernel in a non-production environment, a staging or development server, is crucial to identify any compatibility issues or performance regressions specific to the organization's unique hardware and software stack. Once validated in the test environment, the upgrade is performed on the production system during a scheduled maintenance window, minimizing user impact. Crucially, a documented and tested rollback procedure ensures that if any unforeseen issues arise post-upgrade, the system can be quickly reverted to its previous stable state. This adherence to a structured, tested, and reversible upgrade process aligns with general IT best practices for system stability and disaster recovery, which are implicitly expected in any professional IT environment, even without specific Oracle Linux 6 regulations dictating this exact procedure. The focus is on minimizing disruption and ensuring business continuity. Incorrect approaches analysis. Performing the kernel upgrade directly on the production system without prior testing in a staging environment is a significant regulatory and ethical failure. It demonstrates a disregard for established risk management protocols and a lack of due diligence. This approach exposes the production system to potential instability and data corruption, violating the implicit professional duty to maintain system integrity and availability. It also fails to account for the potential impact on financial transactions, which could lead to regulatory scrutiny if data integrity is compromised. Implementing the kernel upgrade without a comprehensive backup strategy is another critical failure. Backups are fundamental to any IT operation, serving as a primary defense against data loss. The absence of a backup means that, in the event of a catastrophic failure during the upgrade, data recovery would be impossible, leading to irreversible data loss and severe business disruption. This directly contravenes the principle of safeguarding organizational assets and client data. Upgrading the kernel without a documented and tested rollback plan introduces an unacceptable level of risk. While a backup might exist, a rollback plan provides a structured and efficient method to revert to a known good state. Without it, troubleshooting and recovery become ad hoc and time-consuming, increasing downtime and the likelihood of further errors. This lack of preparedness is unprofessional and can have severe consequences for business operations. Professional reasoning. Professionals should approach critical system upgrades with a mindset of proactive risk management. The decision-making process should prioritize system stability, data integrity, and business continuity. This involves a structured approach. 1. Assessment. Understand the criticality of the system and the potential impact of an upgrade failure. 2. Planning. Develop a detailed plan that includes backup, testing, upgrade procedures, and rollback strategies. 3. Testing. Validate all aspects of the upgrade in a non-production environment. 4. Execution. Perform the upgrade during a scheduled maintenance window with minimal disruption. 5. Verification. Thoroughly test the system post-upgrade to ensure stability and functionality. 6. Rollback. Have a clear and tested plan to revert if issues arise. This systematic process ensures that potential problems are identified and addressed before they impact the production environment, upholding professional standards and safeguarding organizational interests. Question 8. To address the challenge of a critical network service failing to respond on an Oracle Linux 6 system, leading to user complaints and potential business impact, which approach best balances rapid restoration with adherence to secure and documented system administration practices? Option A. Manually edit the network configuration files and then attempt to reload the service by directly manipulating network interface configurations. Option B. Employ undocumented commands or scripts found on unofficial forums to force a restart of the network service, prioritizing speed over verification. Option C. Utilize the service command to gracefully restart the network service, ensuring proper initialization and configuration loading. Option D. Directly kill the network service process and then restart it using a basic init script without consulting service management documentation. The correct answer is C. Utilize the service command to gracefully restart the network service, ensuring proper initialization and configuration loading. Explanation. Scenario analysis. This scenario presents a common challenge in advanced system administration, ensuring the integrity and availability of critical system services while adhering to security best practices and operational efficiency. The challenge lies in balancing the need for rapid troubleshooting and recovery with the potential risks introduced by less secure or less tested methods. In a production environment, any deviation from established, secure procedures can lead to data breaches, service disruptions, or compliance violations. The pressure to restore service quickly can tempt administrators to take shortcuts, but the long-term consequences of such actions can be far more severe than the initial downtime. Correct approach analysis. The correct approach involves leveraging the built-in, secure, and documented mechanisms provided by Oracle Linux 6 for service management and troubleshooting. Specifically, using the service command with appropriate arguments to restart or manage the network service is the most professional and compliant method. This approach ensures that the service is managed through its intended lifecycle, allowing for proper logging, dependency handling, and adherence to system-wide configurations. It aligns with best practices for system stability and security, as it avoids manual intervention that could bypass security controls or introduce unintended side effects. This method is inherently auditable and traceable, crucial for compliance and post-incident analysis. Incorrect approaches analysis. Manually editing configuration files and then attempting to reload the service without a proper restart or using undocumented methods to force a service restart bypasses the established service management framework. This can lead to inconsistent states, missed configuration updates, and potential security vulnerabilities if not executed with extreme precision and understanding of the service's internal workings. It is professionally unacceptable because it introduces a high degree of risk, is difficult to audit, and can lead to unpredictable behavior. Furthermore, directly manipulating network interfaces without going through the network service manager can disrupt other network-related processes and configurations, potentially causing broader network instability. Using undocumented or deprecated commands to force a service restart is also a failure, as it relies on internal implementation details that are subject to change and may not be supported in future updates, leading to future operational issues and potential security risks. Professional reasoning. Professionals should approach such situations by first consulting official documentation and established operational procedures. The decision-making process should prioritize security, stability, and auditability. When faced with a service outage, the immediate instinct should be to use the system's native tools for management and troubleshooting. If the standard tools are insufficient, the next step should be to consult advanced documentation or support channels, rather than resorting to ad hoc or undocumented methods. A robust incident response plan should include clear guidelines for service restoration, emphasizing the use of approved procedures. This ensures that all actions are justifiable, repeatable, and minimize risk to the production environment. Question 9. Stakeholder feedback indicates that the Oracle Linux 6 production environment is experiencing intermittent performance degradation, particularly during peak user activity. As the system administrator responsible for this environment, you need to address this concern. Which of the following approaches represents the most professional and effective method for resolving this issue? Option A. Conduct a thorough performance analysis using tools like VMstat, IOStat, and SAR to identify specific bottlenecks and resource contention before proposing any changes. Option B. Advise stakeholders that performance issues are inherent to complex systems and that no immediate action can be taken without further extensive justification. Option C. Implement a broad system-wide optimization script that applies a set of commonly used performance enhancements to all services. Option D. Immediately adjust kernel tuning parameters related to network buffering and memory management to potentially improve responsiveness, as these are common areas for performance tuning. Correct answer is D. Immediately adjust kernel tuning parameters related to network buffering and memory management to potentially improve responsiveness, as these are common areas for performance tuning. Explanation. Scenario analysis. This scenario presents a common challenge in advanced system administration, balancing performance optimization with system stability and security, particularly when dealing with critical production environments. The challenge lies in the potential for unintended consequences when modifying core system parameters. Stakeholder feedback, while valuable, can sometimes be vague or driven by immediate short-term perceptions rather than a comprehensive understanding of system interdependencies. The administrator must exercise sound judgment to interpret this feedback, identify the root cause, and implement a solution that addresses the perceived issue without introducing new risks. The pressure to deliver a quick fix can be high, making a methodical and well-reasoned approach crucial. Correct approach analysis. The correct approach involves a systematic investigation and controlled implementation. This aligns with best professional practices for system administration, emphasizing a proactive and risk-averse methodology. Specifically, it adheres to the principles of change management and incident response, which are implicitly governed by the need for system integrity and availability. By first identifying the specific performance bottleneck through monitoring and analysis, the administrator ensures that the proposed solution directly addresses the root cause. Implementing changes in a controlled manner, such as testing in a staging environment, and then deploying during a maintenance window with rollback procedures, minimizes the risk of service disruption. This approach is ethically sound as it prioritizes the stability and security of the production environment, thereby protecting the organization's operational continuity and data integrity. It also demonstrates professional accountability by ensuring that any changes are well documented and their impact is understood. Incorrect approaches analysis. Implementing a solution without proper diagnosis is a significant professional failure. This approach bypasses essential troubleshooting steps, leading to potential misdiagnosis and the application of ineffective or even detrimental changes. Ethically, this is irresponsible as it risks destabilizing the production environment and impacting users without a clear understanding of the problem. It also violates the principle of due diligence, as a professional is expected to thoroughly investigate issues before implementing solutions. Applying a broad, system-wide tuning parameter without understanding its specific impact on the perceived issue is also professionally unsound. This shotgun approach can have widespread, unforeseen consequences, potentially degrading performance in other areas or introducing security vulnerabilities. It demonstrates a lack of analytical rigor and a failure to consider the interconnectedness of system components. This is ethically problematic because it prioritizes a potentially superficial fix over a robust, well-understood solution, risking broader system instability. Ignoring the stakeholder feedback entirely, while potentially leading to a more stable system in the short term, is also a professional failing. Effective communication and responsiveness to user concerns are vital aspects of system administration. While the feedback may be imprecise, it signals a perceived problem that needs to be acknowledged and investigated. Failing to do so can erode trust and lead to a perception of unresponsiveness, impacting the administrator's professional standing and the IT department's relationship with stakeholders. Professional reasoning. Professionals should approach implementation challenges by first establishing a clear understanding of the problem through data-driven analysis. This involves utilizing monitoring tools, log analysis, and performance metrics to pinpoint the root cause. Once the cause is identified, potential solutions should be evaluated based on their effectiveness, potential risks, and impact on system stability and security. A structured change management process, including testing in non-production environments and planning for rollback, is essential. Communication with stakeholders throughout the process, even if just to acknowledge their feedback and explain the investigative steps being taken, is also critical for maintaining trust and managing expectations. This methodical, risk-aware, and communicative approach ensures that solutions are effective, sustainable, and professionally responsible. Question 10. Strategic planning requires a robust methodology for deploying critical security patches to a production Oracle Linux 6 environment hosting sensitive customer data. The primary objective is to minimize downtime and prevent any data corruption, while ensuring the systems are protected against known vulnerabilities. Given the potential for unforeseen conflicts with existing applications and configurations, what is the most professional and compliant approach to implementing these patches? Option A. Conduct thorough testing of the patches in a dedicated staging environment that precisely mirrors the production setup, followed by a phased rollout to production servers with comprehensive backup and manual verification procedures. Option B. Deploy the patches directly to the production servers during a scheduled maintenance window, relying on automated rollback scripts if issues arise. Option C. Postpone the patching until a complete system overhaul is scheduled, as applying patches to an older Oracle Linux 6 version carries inherent risks that cannot be fully mitigated. Option D. Apply the patches incrementally to individual production servers, monitoring system logs for errors and manually reverting changes on affected servers as needed. The correct answer is B. Deploy the patches directly to the production servers during a scheduled maintenance window, relying on automated rollback scripts if issues arise. Explanation. The scenario presents a common challenge in advanced system administration, ensuring data integrity and availability in a production environment while implementing critical system updates. The professional challenge lies in balancing the need for timely patching to mitigate security vulnerabilities and maintain system performance against the risk of service disruption and data loss. This requires a meticulous approach to planning, testing, and execution, adhering strictly to established operational procedures and regulatory compliance frameworks relevant to Oracle Linux 6 environments. The correct approach emphasizes a phased rollout strategy, starting with a non-production environment that closely mirrors the production setup. This allows for thorough testing of the update's impact on applications, services, and data without jeopardizing live operations. The use of robust backup and rollback procedures is paramount, ensuring that the system can be restored to a stable state in case of unforeseen issues. This methodology aligns with best practices for change management and disaster recovery, which are often implicitly or explicitly mandated by IT governance frameworks and security standards. For Oracle Linux 6, this would involve leveraging tools like Yum for package management, LVM for flexible storage management, and potentially specific Oracle database backup utilities if applicable, all within a documented change control process. Incorrect approaches fail to adequately address the inherent risks. Implementing updates directly on production without prior testing in a staging environment is a direct violation of change management best practices and significantly increases the likelihood of introducing critical errors that could lead to extended downtime and data corruption. This demonstrates a lack of due diligence and a disregard for business continuity. Relying solely on automated rollback mechanisms without a comprehensive manual verification and testing phase is also insufficient. Automation can fail, and without human oversight and validation, a faulty rollback could leave the system in an unstable state. Furthermore, neglecting to document the entire process, including testing results and rollback procedures, creates an audit trail deficiency and hinders future troubleshooting and knowledge transfer, which are essential for maintaining a compliant and secure IT infrastructure. Professionals should employ a structured decision-making process that prioritizes risk assessment and mitigation. This involves understanding the criticality of the systems being updated, the potential impact of failure, and the available resources for testing and recovery. A thorough review of change management policies, security guidelines, and any relevant compliance mandates, e.g., data privacy regulations if applicable to the data handled by the system, should precede any implementation. The decision to proceed with an update should be based on a clear understanding of the testing outcomes and the confidence in the rollback plan. Question 11. Cost-benefit analysis shows that optimizing the I/O subsystem performance for a critical Oracle database running on Oracle Linux 6 could significantly reduce transaction processing times. However, direct kernel parameter tuning is a complex process with potential for system instability if not managed correctly. Which of the following approaches best balances the potential performance gains with the imperative of maintaining system stability and security? Option A. Modify kernel parameters related to I/O in the production environment during peak business hours to observe the immediate impact on live transaction processing and adjust as needed. Option B. Apply a widely published set of universal kernel tuning parameters for high-performance servers, as found on various online forums, directly to the production Oracle Linux 6 system to achieve immediate performance improvements. Option C. Identify specific kernel parameters related to I/O scheduling and buffer management that are known to impact database performance. Research their documented effects and recommended tuning ranges for Oracle workloads. Implement changes incrementally in a staging environment, thoroughly testing performance and stability after each modification, and document all changes and their observed impact before applying them to the production system. Option D. Disable all kernel-level I/O optimizations and rely solely on application-level tuning to avoid any potential kernel-related instability, accepting a potential performance trade-off. The correct answer is C. Identify specific kernel parameters related to I/O scheduling and buffer management that are known to impact database performance. Research their documented effects and recommended tuning ranges for Oracle workloads. Implement changes incrementally in a staging environment, thoroughly testing performance and stability after each modification, and document all changes and their observed impact before applying them to the production system. Explanation. The scenario presents a common challenge in advanced system administration, balancing performance optimization with system stability and security, particularly when dealing with kernel tuning. The professional challenge lies in understanding the intricate dependencies between kernel parameters, their impact on specific workloads, and the potential for unintended consequences. Incorrect tuning can lead to performance degradation, system crashes, or security vulnerabilities, all of which have significant operational and reputational costs. The correct approach involves a systematic, controlled, and well-documented methodology for kernel parameter tuning. This includes thorough research into the specific parameters, understanding their default values and the implications of modification, and implementing changes in a staged manner. Testing in a non-production environment is paramount to validate the effectiveness and stability of the changes before deploying them to production. Furthermore, maintaining detailed records of all modifications, including the rationale, the changes made, and the observed outcomes, is crucial for auditing, troubleshooting, and future reference. This adherence to best practices ensures that performance gains are achieved without compromising system integrity or security, aligning with the implicit regulatory expectation of maintaining reliable and secure IT infrastructure. An incorrect approach of applying a broad set of performance-enhancing kernel parameters without understanding their specific impact on the Oracle Linux 6 environment and its workload is professionally unacceptable. This can lead to unpredictable behavior, system instability, and potential data corruption, violating the ethical obligation to maintain system reliability. Another incorrect approach, that of making changes directly in the production environment without prior testing, bypasses critical validation steps. This significantly increases the risk of introducing critical errors that could lead to downtime, data loss, and service disruption, which can have severe financial and legal repercussions. Failing to document changes is also a significant ethical and professional lapse, hindering troubleshooting efforts and making it impossible to revert to a known stable state, thereby undermining the principles of good system administration and potentially violating audit requirements. Professionals should approach kernel tuning by first identifying the specific performance bottleneck or requirement. This should be followed by in-depth research into relevant kernel parameters, consulting official Oracle documentation and trusted community resources. A phased implementation strategy, starting with a development or staging environment, is essential. Each change should be tested individually and then in combination with other changes, with performance metrics and system stability closely monitored. Comprehensive documentation of all steps, parameters, and observed results is non-negotiable. This systematic and cautious approach minimizes risk and maximizes the likelihood of achieving desired performance improvements while ensuring system stability and security. Question 12. Consider a scenario where an Oracle Linux 6 system is identified as having several potential security vulnerabilities related to network services. The system administrator needs to harden the system to reduce its attack surface. Which of the following actions would be the most professionally sound and secure approach? Option A. Apply the latest available security patches to all network-related packages without first testing them in a staging environment, as patching is always the best security measure. Option B. Download and execute a generic security hardening script found on an online forum without thoroughly reviewing its contents or testing its impact on the system's functionality. Option C. Immediately disable the IPTables service and all other firewall-related services to prevent any potential blocking of legitimate network traffic, assuming that network services themselves are sufficiently secured. Option D. Disable all network services that are not strictly essential for immediate system operation, and then meticulously review and re-enable only those services that are explicitly required, documenting each decision and its justification. Correct answer is D. Disable all network services that are not strictly essential for immediate system operation, and then meticulously review and re-enable only those services that are explicitly required, documenting each decision and its justification. Explanation. This scenario presents a professional challenge due to the critical nature of system security and the potential for unauthorized access. The administrator must balance the need for robust security with the operational requirements of the system, ensuring that any changes do not inadvertently create vulnerabilities or violate established security policies. The core of the challenge lies in implementing security measures without compromising system stability or introducing new attack vectors. The correct approach represents best professional practice because it adheres to a systematic, documented, and tested methodology for security hardening. This involves understanding the specific vulnerabilities being addressed, selecting appropriate tools and configurations, and verifying their effectiveness through rigorous testing in a controlled environment before deployment. This methodical process minimizes the risk of unintended consequences and ensures compliance with security best practices, which are implicitly expected in any professional IT environment, even if not explicitly codified by a specific Oracle Linux 6 regulation. The focus on minimizing the attack surface and implementing layered security is a fundamental tenet of secure system administration. An incorrect approach that involves disabling security services without a clear understanding of their function or impact is professionally unacceptable. This demonstrates a lack of due diligence and a disregard for established security principles. Such an action could lead to significant security breaches, exposing sensitive data and compromising system integrity. Ethically, an administrator has a responsibility to maintain the security of the systems under their care, and arbitrarily disabling security features violates this trust and professional obligation. Another incorrect approach that relies on unverified third-party scripts or configurations without thorough review and testing is equally problematic. This introduces an unknown element of risk. The scripts might contain malicious code, introduce misconfigurations, or be incompatible with the existing system, leading to instability or security vulnerabilities. Professional practice demands that all changes be understood, validated, and tested to ensure they meet security and operational requirements. A third incorrect approach that involves applying security patches without understanding their implications or testing their compatibility could lead to system instability or unexpected behavior, potentially disrupting critical operations. While patching is essential, a haphazard approach can be as detrimental as no patching at all. Professional decision-making in such situations requires a thorough risk assessment, a clear understanding of the proposed changes, and a phased implementation strategy with rollback capabilities. The professional decision-making process for similar situations should involve 1. Threat assessment. Identify potential threats and vulnerabilities specific to the system and its environment. 2. Solution identification. Research and evaluate potential security solutions, considering their effectiveness, compatibility, and potential side effects. 3. Proof of concept/testing. Implement and test the chosen solution in a non-production environment to validate its functionality and security impact. 4. Implementation plan. Develop a detailed plan for deployment, including rollback procedures. 5. Monitoring and verification. Continuously monitor the system after implementation to ensure ongoing security and stability. Question 13. The investigation demonstrates that a critical database service on an Oracle Linux 6 system is intermittently failing to respond to client requests, causing significant business disruption. The system administrator suspects a recent configuration change might be the cause, but the exact nature of the change and its impact are unclear. The immediate pressure is to restore service as quickly as possible. Which of the following approaches represents the most professional and responsible course of action to resolve this issue while adhering to advanced system administration best practices? Option A. Access the production server, identify the most recent configuration files that were modified, and manually revert them to their previous state without testing the impact on the database service. Option B. Apply the latest available security patch for the database software and operating system, assuming it will resolve any underlying issues, and then restart the database service. Option C. Develop a targeted fix based on the suspected configuration issue. Thoroughly test the fix in a staging environment that closely mirrors the production setup, and then schedule a maintenance window for controlled deployment with a documented rollback plan. Option D. Immediately revert the system to a known good snapshot taken prior to the suspected configuration change, and then investigate the change offline. The correct answer is D. Immediately revert the system to a known good snapshot taken prior to the suspected configuration change, and then investigate the change offline. Explanation. Scenario analysis. This scenario presents a common challenge in advanced system administration, ensuring the integrity and availability of critical services while adhering to strict security policies and operational constraints. The professional challenge lies in balancing the immediate need for a functional system with the long-term implications of security vulnerabilities and potential data corruption. The requirement to maintain a secure and compliant environment, especially in a production setting, necessitates a methodical and well-documented approach to system changes. The pressure to restore service quickly can lead to shortcuts that compromise security or stability, making careful judgment and adherence to established procedures paramount. Correct approach analysis. The correct approach involves a systematic process of identifying the root cause of the service disruption, developing a targeted solution, thoroughly testing that solution in a non-production environment, and then implementing it with proper change control and rollback procedures. This aligns with best professional practices for system administration, emphasizing a proactive and risk-averse methodology. Specifically, it adheres to the principles of minimizing downtime through planned maintenance, ensuring data integrity by testing fixes before production deployment, and maintaining auditability through documentation and change logs. This approach directly supports the operational and security objectives expected of an Oracle Linux 6 Advanced System Administrator, ensuring that system changes are controlled, predictable, and reversible. Incorrect approach is analysis. Implementing a fix directly on the production server without prior testing introduces significant risks. This approach bypasses crucial validation steps, potentially leading to further system instability, data corruption, or the introduction of new security vulnerabilities. From a regulatory and ethical standpoint, this is unacceptable, as it demonstrates a disregard for established operational procedures designed to protect the integrity and availability of the system and its data. It also fails to provide an auditable trail of the troubleshooting and resolution process. Applying a generic patch or update without a thorough understanding of its impact on the specific service and its dependencies is also professionally unsound. While updates often address security issues, they can also introduce regressions or incompatibilities. This approach lacks the targeted analysis required to resolve the specific problem and could inadvertently break other functionalities or introduce new issues, violating the principle of least privilege and controlled change. Reverting to a previous snapshot or backup without investigating the root cause of the current issue is a reactive measure that does not address the underlying problem. While it might restore service temporarily, the original vulnerability or misconfiguration will likely persist, leading to recurrence of the issue. This approach fails to learn from the incident and improve system resilience, representing a failure in proactive system management and problem resolution. Professional reasoning. Professionals should approach such situations by first prioritizing data integrity and system stability. The decision-making process should involve a structured incident response plan that includes clear problem identification, root cause analysis, solution design, rigorous testing, in a staging or development environment that mirrors production, controlled implementation with rollback plans, and post-implementation verification. Documentation at each stage is critical for auditing, knowledge sharing, and future reference. Adherence to change management policies and procedures is non-negotiable. Question 14. Upon reviewing a critical security patch for a core application running on an Oracle Linux 6 production server, the system administrator identifies that the patch requires a kernel module update. The administrator has limited time before the next business cycle begins and is considering the most efficient method to deploy this update to ensure system security and stability. Option A. Apply the kernel module update to a development server that has a similar operating system version, but a different hardware configuration, and then proceed with the production deployment. Option B. Create a staging environment that is a near-exact replica of the production server's hardware and software configuration. Test the kernel module update and application functionality thoroughly in this environment, and then schedule the update for production during a planned maintenance window. Option C. Inform management of the security risk and request an extended downtime to perform extensive manual testing of the kernel module update on the production server itself before applying it. Option D. Deploy the kernel module update directly to the production server during a brief maintenance window, followed by a system reboot. The correct answer is D. Deploy the kernel module update directly to the production server during a brief maintenance window, followed by a system reboot. Explanation. Scenario analysis. This scenario presents a common implementation challenge in advanced system administration, ensuring data integrity and system stability during a critical software upgrade on a production Oracle Linux 6 environment. The challenge lies in balancing the need for timely updates to address security vulnerabilities or performance issues with the inherent risks of introducing instability or data corruption. The production environment sensitivity means any misstep can lead to significant downtime, financial losses, and reputational damage. The administrator must make a judgment call on the most robust and least disruptive method for applying the update, considering the specific nature of the software and its dependencies. Correct approach analysis. The correct approach involves performing a staged rollout, starting with a non-production environment, development, or staging that closely mirrors the production setup. This allows for thorough testing of the upgrade process, verification of application functionality, and identification of potential conflicts or performance regressions without impacting live users. If issues arise, they can be addressed and resolved in the controlled test environment before proceeding to production. This methodology aligns with best practices for change management and risk mitigation in IT operations, ensuring that only thoroughly validated changes are deployed to critical systems. While not explicitly a regulatory requirement for Oracle Linux 6 itself, this approach is foundational to IT governance frameworks that emphasize system availability, data integrity, and security, which are often implicitly or explicitly mandated by broader industry standards and compliance requirements, e.g., SOX for financial data, HIPAA for healthcare data. Though these are not specific to Oracle Linux 6 direct regulatory framework, but represent common operational contexts. Incorrect approaches analysis. Directly applying the update to the production environment without prior testing is a significant professional failure. It bypasses essential validation steps, dramatically increasing the risk of system downtime, data corruption, or application failure. This reckless approach demonstrates a disregard for operational stability and business continuity, which are core tenets of responsible system administration. Ethically, it fails to uphold the duty of care owed to the organization and its users. Applying the update only to a development environment that does not accurately reflect the production configuration is also professionally unsound. While better than no testing, A poorly configured test environment can lead to false positives or negatives, meaning issues that would occur in production might be missed, or issues that don't exist might be flagged. This still introduces an unacceptable level of risk to the production system. Attempting to apply the update during a scheduled maintenance window without any prior testing is a marginal improvement over direct application, but still carries substantial risk. A maintenance window provides a buffer for downtime, but does not mitigate the risk of the update itself causing unforeseen problems that could extend beyond the window or lead to data loss. The core failure remains the lack of a controlled, representative testing environment. Professional reasoning. Professionals in system administration must adopt a risk-based approach to change management. The decision-making process should prioritize the stability and integrity of production systems. This involves 1. Understanding the criticality of the system and the potential impact of failure. 2. Thoroughly assessing the risks associated with any proposed change. 3. Implementing a phased approach to testing and deployment starting with the least impactful environments. 4. Documenting all changes and testing procedures. 5. Having a rollback plan in place. This systematic approach ensures that changes are implemented efficiently and effectively while minimizing the potential for negative consequences, thereby upholding professional standards and organizational trust. Question 15. Risk assessment procedures indicate a critical security vulnerability has been identified in a core network service running on an Oracle Linux 6 production server. A patch is available, but applying it requires a system reboot, and the service is essential for ongoing business operations. What is the most professional and secure approach to mitigate this vulnerability? Option A. Inform management of the vulnerability and recommend delaying the patch application until the next major system upgrade cycle to avoid any potential disruption. Option B. Immediately apply the patch to the production server to address the critical vulnerability as quickly as possible, accepting the risk of potential service interruption. Option C. Apply the patch to the production server during normal business hours, notifying users of a potential brief service interruption. Option D. Schedule a maintenance window during off-peak hours. Apply the patch in a staging environment that mirrors production for testing, verify functionality, and then apply to production during the scheduled window with a tested rollback plan. The correct answer is D. Schedule a maintenance window during off-peak hours. Apply the patch in a staging environment that mirrors production for testing, verify functionality, and then apply to production during the scheduled window with a tested rollback plan. Explanation. Scenario analysis. This scenario presents a common challenge in advanced system administration, ensuring the integrity and availability of critical system services while implementing necessary security patches. The professional challenge lies in balancing the immediate need for security updates with the potential for service disruption and data loss. A misstep can lead to significant downtime, financial losses, and reputational damage. The requirement to adhere strictly to Oracle Linux 6 specific best practices and regulatory frameworks, as implied by the exam context, adds another layer of complexity, demanding precise knowledge of the operating system's features and limitations. Correct approach analysis. The correct approach involves a phased, controlled deployment of the security patch. This begins with thorough testing in a non-production environment that mirrors the production setup as closely as possible. This allows for the identification of any compatibility issues or unintended side effects before they impact live services. Following successful testing, a scheduled maintenance window is crucial. This minimizes disruption to users and business operations. During the window, the patch is applied, followed by immediate verification of service functionality and system stability. Rollback procedures must be predefined and tested to ensure a swift return to the previous state if critical issues arise. This methodical approach aligns with best practices for change management and risk mitigation, ensuring system security without compromising operational continuity. Incorrect approach is analysis. Applying the patch directly to the production system without prior testing is a significant regulatory and ethical failure. It demonstrates a disregard for risk assessment and change management protocols, potentially violating internal IT policies and industry best practices that mandate controlled deployments. This approach prioritizes speed over safety, leading to an unacceptable risk of service interruption and data corruption. Implementing the patch during peak operational hours without a scheduled maintenance window is also professionally unacceptable. This directly impacts users and business operations, causing potential financial losses and reputational damage. It violates the principle of minimizing disruption and demonstrates a lack of consideration for the business impact of IT operations. Ignoring the patch entirely due to fear of downtime is a critical security lapse. While system availability is important, neglecting security vulnerabilities exposes the system to exploitation, which can lead to far more severe consequences than planned downtime, including data breaches and regulatory noncompliance. This approach fails to uphold the fundamental responsibility of maintaining a secure IT environment. Professional reasoning. Professionals should approach such situations by first understanding the criticality of the service and the severity of the vulnerability addressed by the patch. A risk assessment should be performed, evaluating the potential impact of applying the patch versus the risk of not applying it. The decision-making process should prioritize a controlled, tested, and scheduled deployment. This involves 1. Thoroughly understanding the patch and its dependencies. 2. Creating a detailed test plan for a staging environment. 3. Scheduling a maintenance window that minimizes business impact. 4. Developing and testing a rollback plan. 5. Executing the deployment with careful monitoring. 6. Verifying system functionality post-deployment. This structured approach ensures that security is enhanced while operational stability is maintained, reflecting a mature and responsible system administration practice. Question 16. Examination of the data shows unusual system activity on a critical server, suggesting a potential security incident. As the system administrator, you need to investigate the source of this activity by reviewing system logs. However, you are concerned about inadvertently altering the logs or exposing sensitive user information during your investigation. Which of the following actions best adheres to professional and ethical standards for system administration in this context? Option A. Grant broad read access to the /var/log directory for all team members involved in the incident response to allow them to conduct their own independent log analysis. Option B. Temporarily disable the logging for the service exhibiting unusual activity to reduce the volume of data you need to sift through. Option C. Directly edit the log files to remove entries that appear unrelated to the suspected incident, thereby streamlining your investigation. Option D. Utilize the audit system's built-in log viewing and analysis tools to examine historical audit data, ensuring that no modifications are made to the log files themselves. The correct answer is D. Utilize the audit system's built-in log viewing and analysis tools to examine historical audit data, ensuring that no modifications are made to the log files themselves. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the ethical responsibility to maintain data integrity and user privacy, particularly when dealing with sensitive system logs. The administrator is tasked with investigating a potential security breach, but the methods employed must not violate established privacy policies or introduce further security risks. The core dilemma lies in balancing the need for thorough investigation with the obligation to protect user data and adhere to system usage guidelines. The potential for misinterpreting log data or inadvertently exposing private information adds layers of complexity, demanding careful judgment and adherence to established protocols. Correct approach analysis. The correct approach involves leveraging the audit logging system's built-in capabilities for secure and authorized access to historical data. Oracle Linux 6, in line with general system administration, best practices, and regulatory considerations for data handling. Even without specific US/UK/O mandates, the principles of data integrity and privacy are universal in IT, provides mechanisms for reviewing logs without direct modification or unauthorized access. This approach ensures that the investigation is conducted in a forensically sound manner, preserving the integrity of the evidence. It upholds the principle of least privilege by using authorized tools and methods, minimizing the risk of accidental data alteration or exposure. This aligns with the ethical imperative to conduct investigations responsibly and transparently within the defined scope of administrative duties. Incorrect approach is analysis. One incorrect approach involves directly editing log files to remove potentially irrelevant entries. This action is a severe ethical and regulatory failure. It compromises the integrity of the audit trail, making it impossible to reconstruct events accurately. This is a direct violation of data integrity principles, which are foundational to any security investigation and often mandated by compliance frameworks. Furthermore, it could be construed as an attempt to conceal information, leading to severe professional repercussions and potential legal liabilities. Another incorrect approach is to grant broad, ad hoc access to the log directory to non-authorized personnel for their own investigation. This violates the principle of least privilege and introduces significant security risks. Sensitive system information, including user activity and potential vulnerabilities, be exposed to individuals without a legitimate need to know, increasing the attack surface and potentially leading to further breaches. This also bypasses established security protocols for data access and review, which are crucial for maintaining a secure and compliant environment. A third incorrect approach is to disable logging for the affected service temporarily to reduce the volume of data. This is a critical failure, as it creates a blind spot in the system's security monitoring. Any activity occurring during the disabled logging period would be unrecorded, making it impossible to detect or investigate future incidents effectively. This directly undermines the purpose of audit logging and is a clear contravention of security best practices and any regulatory requirement for continuous monitoring. Professional reasoning. Professionals facing such dilemmas should first consult established organizational policies and procedures regarding security incident investigation and data handling. They should then utilize authorized administrative tools and methods that preserve data integrity and adhere to the principle of least privilege. When in doubt, seeking guidance from senior administrators, security officers, or legal counsel is paramount. The decision-making process should prioritize maintaining a verifiable and uncompromised audit trail, protecting user privacy, and ensuring compliance with all applicable guidelines and regulations. Question 17. The performance metrics show a consistent increase in application response times and occasional system unresponsiveness. You suspect a resource bottleneck is impacting the application's ability to process requests efficiently on an Oracle Linux 6 system. Which of the following diagnostic and resolution strategies would be the most appropriate and professional approach? Option A. Restart the application server and the database server without further investigation, as this often resolves transient performance glitches. Option B. Immediately increase the allocated RAM and CPU resources for the virtual machine hosting the application, as this is a common solution for performance issues. Option C. Analyze system logs and utilize performance monitoring tools like SAR, IStat, and VMstat to identify specific resource contention, CPU memory, I/O network, and then implement targeted optimizations based on the findings. Option D. Disable non-essential background services and daemons to free up system resources, assuming they are contributing to the slowdown. The correct answer is B. Immediately increase the allocated RAM and CPU resources for the virtual machine hosting the application, as this is a common solution for performance issues. Explanation. This scenario presents a common challenge in system administration, identifying and resolving performance bottlenecks without introducing new issues or violating established operational guidelines. The professional challenge lies in accurately diagnosing the root cause of the performance degradation, which could stem from various system components, and then implementing a solution that is both effective and compliant with Oracle Linux 6 best practices and any applicable internal service level agreements, SLAs, or operational policies. The need for deep analysis is paramount, as a superficial fix could mask underlying problems or negatively impact other system functions. The correct approach involves a systematic, data-driven investigation using Oracle Linux 6 tools to pinpoint the resource contention. This might include analyzing CPU utilization with TOP or SAR, I/O wait times with IStat, memory usage with Free or VMstat, and network traffic with Netstat or TCP dump. Once the bottleneck is identified, implementing a targeted optimization, such as tuning kernel parameters, optimizing application configurations, or adjusting storage I/O scheduling, represents best professional practice. This is because it directly addresses the diagnosed issue, minimizes potential side effects, and aligns with the principle of least privilege and efficient resource utilization, which are foundational to stable and performant systems. Incorrect approaches fail to adhere to these principles. For instance, indiscriminately increasing system resources without a clear diagnosis is inefficient and can mask underlying software or configuration issues, leading to wasted resources and potentially higher operational costs. This could be seen as a failure to exercise due diligence in resource management. Another incorrect approach might involve disabling critical system services to free up resources. This is a severe ethical and professional failure, as it directly compromises system integrity and availability, potentially violating SLAs and leading to data loss or service disruption. Such an action demonstrates a lack of understanding of system dependencies and a disregard for operational stability. A third incorrect approach could be to rely solely on anecdotal evidence or guesswork rather than empirical data. This is professionally unsound, as it introduces a high risk of misdiagnosis and ineffective solutions, potentially exacerbating the problem and eroding trust in the system administration team. The professional decision-making process should involve a structured troubleshooting methodology. First, clearly define the problem and its impact. Second, gather relevant data using appropriate diagnostic tools. Third, form hypotheses about the root cause. Fourth, test these hypotheses systematically. Fifth, implement the most likely solution. And finally, monitor the system to confirm the resolution and observe for any unintended consequences. This iterative process ensures that solutions are evidence-based and minimize risk. Question 18. Operational review demonstrates that a critical business application is currently running on an Oracle Linux 6 system that has reached its end of life for Premier support, meaning it no longer receives security updates from Oracle. The application is essential for daily operations, and its downtime would cause significant financial losses. The development team has indicated that porting the application to a newer, supported operating system would take several weeks, and a quick workaround is urgently needed to restore full functionality. What is the most responsible course of action for the system administrator? Option A. Attempt to find and apply unofficial community-sourced security patches for Oracle Linux 6 to mitigate immediate vulnerabilities while the application is still running on the old system. Option B. Immediately deploy the application on the unsupported Oracle Linux 6 system, prioritizing immediate service restoration over potential future security risks. Option C. Continue operating the application on the unsupported Oracle Linux 6 system without any changes, assuming that the risk of exploitation is low and that the business cannot afford any downtime. Option D. Investigate and implement a temporary, isolated virtual machine environment running a supported operating system and migrate the application there, even if it requires a short, planned downtime for the migration. The correct answer is B. Immediately deploy the application on the unsupported Oracle Linux 6 system, prioritizing immediate service restoration over potential future security risks. Explanation. Scenario analysis. This scenario presents a professional challenge due to the conflict between immediate operational needs and the long-term security implications of using unsupported software. The administrator is under pressure to restore service quickly, but doing so with outdated and unpatched software introduces significant security risks. The challenge lies in balancing the urgency of the business requirement with the responsibility to maintain a secure and compliant system environment, adhering to Oracle Linux 6 best practices and security guidelines. Correct approach analysis. The correct approach involves prioritizing the upgrade or replacement of the unsupported Oracle Linux 6 system. This aligns with the fundamental principles of system administration and security, which mandate the use of supported and patched software. Oracle Linux 6 is well past its end of life for Premier support, meaning it no longer receives security updates or bug fixes from Oracle. Continuing to run, it exposes the system to known vulnerabilities that could be exploited, leading to data breaches, service disruptions, and potential compliance violations. The ethical and professional responsibility is to mitigate these risks proactively, even if it requires a temporary service interruption or a more involved solution than a quick workaround. This approach ensures the long-term integrity and security of the system and the data it handles. Incorrect approaches analysis. One incorrect approach involves immediately deploying the application on the unsupported Oracle Linux 6 system without any mitigation. This is professionally unacceptable because it knowingly introduces a critical security vulnerability. The absence of security patches for Oracle Linux 6 means that any exploit targeting known weaknesses in the operating system or its components could compromise the entire system. This directly violates the principle of due diligence in system administration and could lead to severe consequences, including data loss, reputational damage, and legal liabilities. Another incorrect approach is to attempt to manually patch the Oracle Linux 6 system with unofficial or community source patches. While seemingly a proactive step, this is highly risky and unprofessional. Unofficial patches are not vetted by Oracle, may not be compatible with the Oracle Linux 6 environment, and could introduce new instabilities or security flaws. Relying on such patches undermines the integrity of the system and is not a sustainable or secure solution. It also bypasses established support channels and best practices for enterprise operating systems. A third incorrect approach is to simply ignore the unsupported status and continue operating as is, hoping no vulnerabilities are exploited. This demonstrates a severe lack of professional responsibility and foresight. It is akin to leaving a building with known structural weaknesses unaddressed, assuming it won't collapse. The ethical failure here is the passive acceptance of risk, which endangers the organization's assets and operation. It also fails to uphold the administrator's duty to maintain a secure and reliable IT infrastructure. Professional reasoning. Professionals should employ a risk-based decision-making process. When faced with a situation involving unsupported software, the first step is to identify the risks associated with its continued use. This includes security vulnerabilities, lack of vendor support, and potential compliance issues. The next step is to evaluate the available options for remediation, such as upgrading to a supported version, migrating to a new platform, or replacing the application. The chosen solution should prioritize security, stability, and long-term maintainability, even if it requires a greater initial investment of time or resources. Open communication with stakeholders about the risks and proposed solutions is also crucial. Question 19. Analysis of a critical Oracle Linux 6 server experiencing intermittent performance issues. A system administrator discovers that the kernel is running an outdated version with a known, unpatched security vulnerability. The business is urgently requesting the server be brought back to full performance to avoid significant financial losses. What is the most responsible course of action for the administrator to take? Option A. Initiate an immediate, full operating system upgrade to the latest Oracle Linux version without prior testing or stakeholder consultation. Option B. Document the vulnerability, assess the risk, and propose a controlled patching or upgrade plan to management, while exploring temporary documented mitigation strategies if absolutely necessary and approved. Option C. Immediately apply a patch found on an unofficial online forum, as it claims to resolve the specific kernel vulnerability and restore performance. Option D. Ignore the kernel vulnerability, as the server is protected by a firewall and intrusion detection system, and focus solely on performance tuning. Correct answer is B. Document the vulnerability, assess the risk, and propose a controlled patching or upgrade plan to management, while exploring temporary documented mitigation strategies if absolutely necessary and approved. Explanation. Scenario analysis. This scenario presents a common ethical dilemma in system administration, balancing the immediate need for system stability with the potential long-term security implications of using unpatched legacy software. The challenge lies in the pressure to restore service quickly versus the responsibility to maintain a secure and compliant environment. The administrator must consider the potential impact of a security breach, data loss, and regulatory noncompliance, all while facing operational demands. Correct approach analysis. The correct approach prioritizes security and compliance by acknowledging the risks associated with the unpatched kernel. While a temporary workaround might seem appealing for immediate service restoration, it bypasses established security protocols and potentially violates the spirit, if not the letter, of security best practices and any applicable Oracle Linux 6 support policies. The best professional practice involves documenting the issue, seeking approval for a controlled upgrade or patch deployment, and communicating the risks and mitigation strategies to stakeholders. This aligns with the principle of least privilege and defense in depth, ensuring that systems are maintained in a secure and supported state. Oracle Linux 6, while older, still has support lifecycles and security advisories that must be adhered to. Ignoring these can lead to vulnerabilities that are known and exploitable. Incorrect approaches analysis. One incorrect approach involves immediately applying a community source patch without proper vetting or testing. This is a significant security risk. Such patches may not be thoroughly tested, could introduce new vulnerabilities, or might not be compatible with the specific Oracle Linux 6 environment, leading to further instability or data corruption. This action bypasses established change management processes and introduces unverified code into a production system, which is a direct violation of responsible system administration practices and potentially any internal IT policies regarding software deployment. Another incorrect approach is to simply ignore the kernel vulnerability and continue operating the system as is, relying on network-level security measures. This is a failure to address the root cause of the vulnerability. While network security is important, it is not a substitute for patching known vulnerabilities at the operating system level. This approach leaves the system exposed to exploits that target the kernel directly, potentially bypassing network defenses. It also demonstrates a lack of proactive security management and could lead to a breach that is difficult to attribute to a specific failure if not addressed. Furthermore, it may violate compliance requirements that mandate timely patching of known vulnerabilities. A third incorrect approach is to immediately propose a full system upgrade to a newer Oracle Linux version without fully assessing the impact or necessity. While upgrading is often the long-term solution, a hasty decision without proper planning, testing, and stakeholder buy-in can lead to significant downtime, compatibility issues with applications, and unexpected costs. This approach, while seemingly proactive, lacks the measured, risk-based decision-making required for critical system changes. It prioritizes a drastic solution over a potentially simpler, more targeted fix, and fails to consider the immediate operational impact. Professional reasoning. Professionals should employ a risk-based approach. First, assess the severity of the vulnerability and the likelihood of exploitation in the specific environment. Second, consult official Oracle Linux 6 documentation and security advisories for recommended actions. Third, follow established change management procedures, which typically involve documenting the issue, proposing solutions with risk assessments, obtaining approvals, and planning for testing and deployment. Communication with stakeholders, including management and application owners, is crucial throughout the process to manage expectations and ensure informed decision-making. The goal is to restore service securely and reliably, not just quickly. Question 20. Process analysis reveals that user complaints regarding slow system response times on Oracle Linux 6 servers have increased. To address this, a system administrator proposes analyzing user activity logs to identify performance bottlenecks. However, these logs contain sensitive information about user actions. What is the most appropriate course of action for the administrator to take? Option A. Immediately begin analyzing the user activity logs to identify performance issues, as system performance is a critical operational requirement that supersedes privacy concerns in this context. Option B. Anonymize the user activity logs by removing all identifying information before analysis, assuming this fully addresses privacy concerns without further consultation. Option C. Inform users that their activity logs will be analyzed to improve system performance, and proceed with the analysis if no immediate objections are raised. Option D. Obtain explicit authorization from management and consult with the legal department or data protection officer to ensure compliance with privacy policies and regulations before accessing or analyzing user activity logs. The correct answer is D. Obtain explicit authorization from management and consult with the legal department or data protection officer to ensure compliance with privacy policies and regulations before accessing or analyzing user activity logs. Explanation. Scenario analysis. This scenario presents a professional challenge rooted in the ethical dilemma of data privacy versus system performance optimization. The administrator is tasked with improving system responsiveness, a common and legitimate goal. However, the proposed method involves accessing and analyzing sensitive user activity logs, which are protected by strict privacy regulations. The challenge lies in balancing the technical imperative to enhance system efficiency with the legal and ethical obligation to safeguard user data. The administrator must navigate the potential for misuse of this data, the lack of explicit user consent for such analysis, and the risk of violating established privacy policies and potentially Oracle Linux 6 specific security guidelines if not handled with extreme care. Correct approach analysis. The correct approach prioritizes adherence to regulatory frameworks and ethical best practices. It involves seeking explicit authorization and clearly defining the scope and purpose of any data analysis. This aligns with the principles of data minimization and purpose limitation, which are fundamental to data privacy. By consulting with legal counsel and the data protection officer, the administrator ensures that any actions taken are compliant with relevant Oracle Linux 6 security guidelines and any applicable U.S. federal or state privacy laws that might govern data handling on such systems. This proactive approach mitigates legal risks and upholds user trust by demonstrating a commitment to privacy. Obtaining documented consent or a clear policy outlining such analysis is crucial for ethical and legal compliance. Incorrect approach is analysis. Proceeding with the analysis without explicit authorization or a clear policy is a significant regulatory and ethical failure. This bypasses established data governance procedures and potentially violates user privacy rights. It could be construed as unauthorized access to sensitive information, leading to legal repercussions and reputational damage. Furthermore, it sets a dangerous precedent for future data handling, eroding trust within the organization and with its users. Such an action disregards the principle of least privilege and the need for transparency in data processing. It also fails to consider the potential for unintended consequences, such as the exposure of personally identifiable information, PI, or the discovery of sensitive user activities that are not relevant to system performance. Professional reasoning. Professionals in system administration must adopt a risk-aware and compliance-focused decision-making process. When faced with a task that could potentially impact data privacy, the first step should always be to consult existing policies and legal counsel. This involves understanding the regulatory landscape, identifying potential ethical conflicts, and seeking clear documented authorization before proceeding. A robust decision-making framework includes 1. Identifying the objective and the proposed method. 2. Assessing potential risks, including legal, ethical, and security risks. 3. Consulting relevant policies, regulations, and subject matter experts, legal, privacy. 4. Obtaining explicit authorization and defining clear parameters for the action. 5. Documenting all steps and decisions. 6. Implementing the action with strict adherence to approved guidelines and monitoring for compliance.